live. I was having trouble going live on LinkedIn, especially. The best one is YouTube, no questions asked. Twitch is great. Yeah, Facebook, not so much. I'll just have to deal with that. Okay, so we're doing this Kegel competition. I just found about it. It was already going for a while. Was it 2 months ago? There's now a month to go. We're not worried so much about the submitting an actual competition thing, but we're more interested in the data because it's open source. So I have a bunch of labels, bunch of seizures from quite a lot of patients. So I already spent yesterday doing this. We have the this little tool that we made where you can select the EEG ID. So some of them are not so great, some of them are repeats. This doesn't work for some reason. So in theory it does work because we have yeah, so this will be an example of how not to store your data, probably. I don't know when was this data collected, must have been some time ago. So we have data from these different electrodes. There's not too many of them. I don't know why. Normally there would be 20. Obviously there's less here. Or is it a standard montage? Yeah, I think it might be a standard montage. And we have the ECG as well. That in most cases doesn't look very good. Like here, for example. Obviously rubbish. So yeah, no ECG. So you know, if this was a real ECG, this patient might be having other problems other than the EEG recording, and as you can tell, the EEG is not so great either. There's some sort of DC shifts in it, which shouldn't be there. Yeah, a big DC shift here. And so there's a lot of patients, but this data is segmented. It's not continuous data. We don't particularly like segmented data. And yeah, an example of how not to store the data. This would be it. And so what do we have? We have the EEG ID. I think there's 50 seconds of recording, and then there's a sub ID. So in theory, so this first ID there, it's going up to something like 87 seconds. However, it meant to have this 10 sub IDs in it. So we're still figuring out how to display it properly. Yeah, so this is what we have in the training. In the training data, we have a GID, a sub ID. So essentially in each one of those files, you have different labels. In this case, they're all labeled seizure, I think. Yeah, they're all labeled seizure. And say this next ID. Can I? Has only 2 sub IDs, 0 and 1. And this is an interesting bit. So originally it says that for each label, each entry, for each GID, you see duplicates there. So essentially this will be that number 0.0 and then same number 0.1, but then the EEG label offset in seconds. So the first one is at 0, the second one is at 6. So then it's not quite clear. So in theory, the original thing should be just doesn't sound right. This label offsets. So for the second label we have 50 and we have label offset at 0 and 2. Yeah, really weird. Good example of how not to store data 1012. Yeah, this one has 0 and 18. The next one has 0 and 28. So in theory, the offset, let's see again what that offset, the time between the beginning of the consolidated EEG, the time between the beginning of the consolidated EEG. Okay, so even if I assume they are all 50 seconds, the sampling rate is 200, by the way, for this data set. It doesn't make any sense. Two seconds. $52. I mean, it does make sense in terms of the 2 seconds there. We do have 52. Problem is that we meant to be having then 102 seconds of data, because each entry is 50 seconds. There is a essentially 2-second offset. So the length of this recording should have been 100. It's the next one doing 444 at the end. So it's 444. How did these numbers don't add up? Let's check. So 584 at the end. Has it 65, 68? It's 50 plus 18, so that makes sense. But then they're meant to be 118. Same for 710. It will be 78. Yes, 78, but it doesn't make sense. Don't think so. They're both labeled as a seizure. Here you have the agreement on disagreement. Yeah, so those agreements, disagreements are actually quite interesting. Yeah, here you had essentially 16 experts labeling the data. One of them labeled the LPD, one AVA, and 14 labeled as LRDA. There's a description of what each means. LPD is lateralized periodic discharges, GPD, generalized periodic discharges, so that's throughout the brain. Lateralized will be essentially what's called focal, it's called focal seizure, so originating in one area of the brain. Lateralized rhythmic delta activity, GRDA, generalized rhythmic delta activity. And AVA. So you had supposedly up to 16 experts labeling this data. I don't understand why then in this next case only 3 experts did the labeling. In this case there were 13. So is it 12, 14, 15? Yeah, it's good to see some disagreement. In this case, 7 labeled as something as seizure and essentially 8 labeled as AVA. So the consensus was AVA. And that's what you get for the label. And yes, when analyzing this data, I could give priority. So this one will be uncertain because it's like 7 to 8, whereas in other cases you have much higher certainty, like in here where you have 14 experts labeling, putting a specific label. So that's the data we are dealing with. We'll just try and sort out the display. Need to figure out. And yes, there are spectrogram files as well. I mean, probably could make our own spectrogram, but supposedly the spectrograms are a wider time window. So there were expert annotators reviewed a 50-second long EEG samples plus matched spectrograms covering 10-minute window centered at the same time and labeled the central 10 seconds. Many of these samples overlap and have been consolidated. Okay, so this is really weird. Okay, this is another thing of what not to do. So okay, I think I understand now what's going on. So for example, yeah, if you take again say 01, say this example, No, 710 is fine. So in this example, essentially the reviewers labeled two windows of 50 seconds. One was from a 0 to 50, and the other one was from 28 seconds to 50. Therefore, when you look at the whole thing, you have 78 seconds. That does make sense. So the two windows have a high overlap, almost what is it, 70% overlap, which is a bit odd, but okay, just have to deal with it. It was like same case there. Yeah, so if you go in the for the first EEG ID, we have this 90 seconds of stuff, and that's because 50 plus 90. Yeah, so that's the offset. So the reviewers labeled this 10 50-second segments. The first one is from 0 to 50, the second one is from 6 to 56, then 8 to 58, so on and so forth, and the last one will be a 40 to 90. Therefore, the whole segment is 90 seconds. Right. Yeah, not sure why why so many overlaps. You could essentially, the labels are all the same anyway. So that's the other thing. Yeah, I had 3 reviewers, and they're all voted seizure. Right, so they're voting seizure and this other abnormal activity. And would there be label for normal? No. So it's a bit odd, but okay. You do have label for other, whatever that means. Is so originally, obviously, yeah, it would be better. This is not working as expected. It's just yeah, I don't know why something like that is. Yeah, this was labeled as seizure. A seizure. Sure, that's updating correctly. Doesn't look like this one is updating correctly. We have to fix it. Yeah, this is super weird. Yeah, you would just discard something like that. Yeah, that's the. I mean, you can discard based on ECG. Sometimes, like the ECG electrode is not sitting well, but that will be just an indication that that potentially something else is wrong. Like in this case, a 5533. Yeah, I have to check the labels. That thing, are there any cases at all where you have the same EEG ID but the labels are different? Don't think so. Yeah, they're always the same labels anyway. It's kind of silly that way. Yeah, it looks like the extra stuff there is just like fudging, creating more data. It's essentially fake because it's hard to explain. Just a hunch, but not just a hunch, but yeah, we can explain it based on the fact that, yeah, so for example, yeah, they just copy paste of one another. They all have the same scores. They all were scored LRDA, the lateral rhythmic discharges. This patient will have 260. So we expect 260 seconds in this data. It essentially doesn't matter how long that segment is. They were all labeled the same. Just go somewhere into the middle of. Yeah, you can tell. Yeah, this will have the same, exactly the same label, same scoring. These three. This one has a lot. Okay, this is interesting. So no, the scoring was different. So there essentially was just so weird. So how many experts looked at this segment? Is it 3 or 5? Because essentially this one was labeled by 3 experts as seizure. It was eventually labeled as seizure, but interestingly enough, this 3 in the middle was also labeled by essentially another 2 experts that said that one said AVA and one said something else. So not a seizure. But why all 5 didn't label the whole lot? Yeah, which is weird. 3, 16. And it's also suspicious that that in this case, for example, you had 13. So 13 experts. Where do you find 13 experts? Label just this one segment alone. That second one was also labeled by 13. There was a bit more of a disagreement between them. Yeah, this is an interesting one. Yeah, it was eventually labeled a seizure because there was 7 experts labeling it a seizure, but 6 labeled it as something else. Yeah, so even if you take this one as seizure, there is essentially, it's probably not clear cut. Anyway, we want to display all this stuff in our tool and then do more processing. So doing spectrograms and other things. Eventually we'll be training a fuzzy logic to try and do the detection, the classification. Yeah, it's nervous that. Yeah, you shouldn't see things like this probably some sort of motion artifact. Yeah, I can bet the ECG would not be there as well. Yeah, I'll be inclined, and a lot of competitors, whatever they will be doing quite a bit of filtering. I'll be inclined to discard things like that. There's obviously something very wrong. Yeah, that looks like a seizure. Some of the spiking. It's an interesting one. Yeah, we'll have a better tool to review this stuff. Yeah, I want to pull out, for example, seizures that had a very high agreement and a large number of experts. So we want to like do a priority. So those will be like the parameters. There will be some sort of agreement score. There's actually a kappa. What's it? Kappa score? Yeah, I have to look it up. Maybe do that. That essentially should tell you something about the agreement level between experts. And yeah, we'll go from there. Yeah, this one was only labeled by one expert. It's a bit odd. Okay, so what shall we do next? We have this code, we're loading data, we have the data downloaded already. So this is actually a good example for what is more likely to be a seizure. There's still no ECG in it. Yeah, they seem to be spiking on all channels. You can even tell, yeah, and it's more pronounced on some channels than others. There's just the baseline noise is smaller on, is it on one side of the head? So those will be left, was it even numbers will be left side, odd numbers will be right, or the other way around. Doesn't really matter. Yeah, so you have the seizure potentially on both hemispheres. That's why they labeled it a seizure. I don't know why the other labels are the other labels not a seizure. Have to check. Anyway, we have this now working as a Flask application. I mean, if it's doing something useful and you want to access it, we can make it available eventually on biomedical.com. If you haven't checked biomedical.com, go check it out. Sometimes you even get relevant ads for you, and we will add this dataset as our examples. The license permits us using it for educational purposes. Yeah, it's attribution, non-commercial, Creative Commons for a 26.5 gigabyte. That's a zip file. Once you open it, it's obviously larger. Tell you exactly how large. It's still 26.4. So zipping it didn't help much, did it? It's mainly the data is Parquet. I don't know how to pronounce it. Files. So we're opening those. Python can do it fairly easily. Yeah, I like that example because it's obviously looks more like a seizure. And there's 124 seconds of it. The other problem is that there is no onset. Yeah, that's why we prefer continuous time series data, not chopped up segments, because you can see the evolution of the seizure and what's happening before and after is very important. Okay, so we won't be displaying all the channels. You can just use the drop-down window. We will, however, try and sort the sub ID and the label offset. So we'll be displaying only 50 seconds, and then you can select for each ID. We'll have another drop down of the sub ID, and we use the offset in seconds to move it along. So now I understand what it's doing. So I'm not sure GitHub Copilot will be able to sort this for us because it doesn't have all the context. I mean, we have the text file with the data structure, how the files are loaded. Yeah, so sub ID. Sub ID. Let's see. Let's pop that in because it's currently not displaying correctly. Also, ideally, the idea was that you select based on expert consensus based on the label instead of the EEG ID. Currently, you select based on the EEG ID instead. And that looks a lot like baseline EEG. I have to make sure the expert consensus we'll place it below. Yeah, we'll do this quickly and to make sure it's actually, yeah, there's some artifact there. Now one of those that will be ignored. I wonder how they were presented to the expert. What they filtered out somehow. This looks more like EEG. Yeah, so the offset label eventually, if it's actually working, we don't have to display it. And let's see. Yeah, I'm doing a lot of debugging at the moment. That's okay. Okay, so the data for sub ID. Yeah, we have the offset. Okay, so we don't need that. Yeah, we do need this. And the problem is that it's not being shown correctly. EEG sub ID and label offset in seconds are empty on the front end. Yeah, so they're not being populated. Have this populate drop down function. I think it's too generic for our liking. Probably will have to. It's trying to cover all the different cases at the moment. It's an async function, which is good. Okay. Sub ID offset 6, so that's working well. It's really, really good. Let's just double check. Yes, we have the EEG ID and we have this 50-second EEG labels. And say for the sub label of 8, the offset in seconds is 40. So we should be always plotting 50 seconds and using the offset. And this, so the label offset is empty. How to fix the code so it's actually populated the Yeah, hopefully it understands the context. Surprised we are not doing this already. Right. So update label offset display should accept data as the input. That helps, doesn't it? So let's do that. That can go for sure. Okay. And it's not updating. Need to make sure that the input is being used everywhere. It is. Okay, it's working. So it's showing current sub ID. Yeah, we need to fix this bit. Would it understand what the problem is? Update label offset display function is being called before the drop-down value is updated. Okay. Does seem important. Get element by ID. Correct. Yeah, probably don't need all that output at the moment. Console. That's better. It's cleaner. Okay, so we have the subject ID. Sorry, this is not the subject ID. Those look like seizures. Oh, yeah, it looks like something. So we need to make sure a couple things. First, okay, there's an obvious problem here. First of all, I don't know why the label offset also has current sub ID instead of just having the number of seconds in it. And also, so it seemed to display it correctly the first time around, but it's not updating when a different EEG sub ID have been chosen. Yeah, I think we are in business. What's this for a sec? Okay, so when loading, it's just selecting the first EEG ID, sub ID of 0, offset of 0. Right. So that does work. Yeah, ideally, yeah, we don't want to spend too much time on this one. Ideally, when you select an EEG ID, it will show you the whole thing. And when you select the okay, so not sure how hard it will be to do, but ideally we would like when loading, it will select the default EEG ID and show the whole number of seconds, all the data points in it, and only when selecting a specific EEG sub ID, it will focus. Oh, come on. Modify the function fetch data from the default ID and update. That's okay. That's not what I meant. Ideally, will like when loading, it will select the default EEG ID and show the whole number of seconds as it does now. So this is already happening. And now only when selecting a specific EEG sub ID, and the chart will focus on 50, will zoom in on to 50 seconds with the selected offset. So hopefully it understands what I mean. Probably not. Okay, let's see. To implement the switcher, we need to modify fetch and update chart. I also don't understand why do we have a two function fetch and update chart, and then we also have update. Pretty sure we have update chart as well. We'll sort it out later. Don't worry about it. So it's checking if dropdown is populated. If so, right, we do need all this. The complete function. No, it has this rest of the code. Yeah, multiplying by the sampling rate, which is 200. Why is it? Okay. Yeah, everything needs to be multiplied by the sampling rate because this value is in seconds. And once we multiply by sampling rate, it will become the number of data points. Yeah, we have a fetch and update chart, and then we have update chart. It's a bit odd. Yeah, this is where we divide by the sampling rate, which is fixed, a constant of 200. Constant. Yes. Have it defined in the beginning of the code, blah, 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 blah. Okay, an update chart. Normally if we say fix, it will ask what do you want to be fixed. If maybe say fix and update a combine, yeah, we essentially need to for it to regenerate the whole function. That's what we need. Okay, we have offset default value of 0. That's fine. Index SR looking good. Guess what is the 0 there? Guess something stopped working. Must be errors. No, there are no errors. Why? Something is up. No, that is that there is okay. Was the the JavaScript changed correctly or not? Kill it for a sec. Selecting a different EEG ID stopped working. It's not updating the chat anymore. How is it missing? Sub ID event listener changes there. Function. Yeah, change. Yeah, it's just working. That's the the beauty of Copilot. To know how it happened, but there's that bit, well, working again. And then select, yeah, so for example, for this EEG ID, we have sub ID 1, A0 and 1. A0 it's offset 0, 1 is at offset 18. And in theory, when we select that, we should just display a 50 seconds, a 50 seconds of the actual segment. How do we do that? Do we actually need it? When something becomes difficult, you just ask yourself, do you really need it? Maybe we can move on. No, we do need it because those are the labels. The labels are only for 50 seconds. Sure, we had the 50 a fetch and update chart. Yeah, we do have it in the code, but it's not. So in theory, when fetch and update chart, let's do console log there. Yeah, that's right. Yeah, that might be the problem. Yeah, might not need that line anymore. Yeah, the label offset is not required. Label offset ID. You're already displaying it in the sub ID. Yeah, this offset should be taken. Oh, come on. The offset is already being the offset seconds is already being displayed in the EEG sub ID, so I removed it from HTML, and we would like to use it for the offset start index and index calculation. Not use the offset from the sub ID dropdown. Yep, that's right. That's wrong, isn't it? How do we do that? Do we have this function already? Populate drop down if drop down sub ID. Yeah, we have that already. And then update offset display. H data update chart console. Yes. it. Will it actually work? No. Variable is defined and populated, but is not accessible in the fetch data update chat. Async function endpoint JSON return. Return the data. There's no horizontal scroll. It's a bit odd. We're not passing data properly. Those not links. It's crazy because when you just start using it, they are. Yeah, haven't made any changes. Yeah, you probably need to give it the whole code to look at. Let's see if it makes a different suggestion. I haven't changed anything. By the way, if you haven't checked the bionichaos.com, please go do so. There's a lot of interesting tools. Surely you will find something useful there. And when you do, don't forget to provide your feedback. So just an overview, is still trying to display properly this it's at Harvard Medical School harmful brain activity classification dataset. Yeah, particularly focused on the data bit of the code. We want initially to review the data properly. So making this tool where you can ideally eventually is like scroll quickly from through the data to get a better understanding of what the data set is all about. Okay, we're having a problem, obviously, as you can tell. This code, it was working a second ago, so hopefully GitHub Copilot can fix it for us. Yes, it's working again. We should have like some sort of unit test to see if it's working correctly. Yeah, we expect. So what do we expect? This doesn't work. No, we don't need an extra function, that's for sure. Oops. That's not an extra function, we actually have it. So why it can't just regenerate the whole thing, considering Okay, so EEG sub ID. So when we change that, nothing happens. When selecting a different value from the drop down. And when changing the electrode name, we get the following error. And we selected the whole JavaScript code because it's obviously a problem with JavaScript. There's no errors in the backend. Getting data is not an array. The data is I mean, that's how the backend is accessing the data. Yeah, the data could probably be simplified. That is seizure there, it looks like. already have it. Okay, it's working again. Seems like we have a seizure on that. Okay, now changing the electrode from the drop down works well, but when selecting a different EEG sub ID, nothing happens. Pretty sure we have it already. Just updating the value. This one still works. Okay, this one does something. Yeah, they both seem to work, but one is not giving an error. So I don't know what's up with that. Can we check what happens when we select a different EEG sub IT? When do we actually plot the 50-second time window instead of the whole window? Hopefully it understands the context. Shall we do an overview with GPT-4? By the way, this session is meant to be interactive, so if anyone wants to join in for a chat, you can do it via the text chat. Yeah, if anyone wants to team up for this competition, we can do that as well. I never actually submitted any. No, I did, but yeah, it was like way off in the leaderboard. It's currently the leaderboard. Yeah, we'll have to do probably a separate tool on how the score is being calculated. Yeah, so we might what normally happens is that these scores get saturated towards the end because people just keep bombarding submissions. Yeah, so just doing 200 entries and kind of hope for the best. So probably just tweaking parameters slightly and resubmitting and doing it again and again. I think you can submit 5 per day. Yeah, the leaderboard is calculated with approximately 35% of the dataset. The final result will be based on the other 65%. So the final standing may be different. Yeah, this is the other thing. So they only essentially. So how much data is in the training set, like in terms of percentage of all the data? I don't know. And here there is a training set, then there is a testing public set which has only one file in it. That's for your testing, so that one would not be labeled. That's for you to submit the submit your algorithm to get a score, and then later your algorithm will be run on a much larger data set for you to get the final score. And obviously unfortunately we don't have access to the data set. I don't know if it will be available at the end of the competition. Probably not, but yeah. So currently we have this display. You can select your EEG ID. This one looks like it's having seizures and something. Can we make sure? Yeah, we also need to make sure when we select different ID that the expert consensus is updated. Actually, it should be is the patient ID being updated? No. Yeah, I get a lot of noisy stuff. Oh, we just had one noisy channel. Yeah, it's some probably muscle, probably EMG in there. Looks like a classic EMG. We have to look at its frequency component. Should have a higher frequency component, so that's what we will do later. Not sure if today or not. See how the GPT gods are behaving or not. They're actually behaving well. We will be making much quicker progress. Yes, I did understand, even though there was a misspelling in the voice to text transcription. Still understood the context. And that is wrong. Let's rewrite it. We're selecting mainly working with JavaScript at the moment. The code is being fetched. Okay. This is the 50 seconds time window. Can we check what happens when we select different EEG sub ID? When do we actually plot the 50-second time window instead of the whole window? Yeah, it's not very clear. Let's see if it understands the context. By the way, that label we will just yeah, we have to modify it. I've change it into a display instead of input. Just do it as an output. When you select the specific a 50-second label, it will just show you what the label is. Let's read that quickly. Selected IG electrodes of the parameter provided, corresponding element data. It's plotted, fetched, and update that chat. After checking that the necessary dropdowns are populated, then the selected ID are valid. Right, so the expectation is that, so when we select oh, that's really bad. There's something in the ECG. Yeah, obviously something like that can be just ignored outright. It's going plus minus 2000 as well. Get rid of it. come it became slower. Yeah. Yeah, you can tell there's a lot of problems with the dataset. Yeah, a lot of baseline drifts. I don't know what it is, just bad recording. Surprisingly, ECG is good. It's actually there. And looks legit. But what on earth is going on? The EEG, you get the square waves. This is obviously not what the brain is producing. You only have one ID, so this will be 50 seconds. That's correct. So at least it makes sense in terms of the timing of it. Yeah, I'll see. I'll have some sort of filtering thing. A filtering, I'm thinking, so you don't want to try and filter something like that. I mean, you want to just get rid of it. This is just real bad. So why became much slower? Would mean there's some sort of a memory leak, which would be highly it would be really bad if there is. Stopped for a sec. Yes, we expect this fetch. Yeah, why are the start and end on nans? That's not cool. Sure, it should just understand the context. Yeah, not a number issue, the calculation of the start and end. It's the same function. Calculates the start and end indices based on the offset and the sampling rate. So this calculation there. Why is this not being used? Let's troubleshoot this function. Pretty sure it should be accessed somewhere. I'm pretty sure it is needed. Is it needed? It's really weird. Log the data. Need to figure out why. Yeah, let's log this to okay, offset. Is that okay? No, that is undefined. What? How is it not giving an error? Turn error if data why is it refusing to write code? I just doesn't want to. Anyway, the data is undefined, which is not cool. question is the start index. Silly thing. Let's pop it also into GPT-4 so we can get the bot to explain the code and everything. Let's start a new chat quickly. Quickly. We have script.js, the Flask app, the data utilities. It's actually probably not really needed. Hey, can you explain the whole code and give a broader context for the application, how it can be used, what is it for? And more specifically, we're still trying to modify the code to make it better. The current problem is that when we select a sub ID, EEG, the offset seem to only change the x-axis label, but not actually move the data, not actually fetch new data of only 50 seconds. Can we need to test that. Yep. Okay, so this is the summary by ChatGPT. I'm still listening to it, but I'm gonna just take a quick break.
Got it. You've got a web application for viewing EEG, electroencephalogram data. It looks like it's designed for analyzing and visualizing EEG data, probably to assist in identifying harmful brain activities like seizures or other abnormal patterns. The app lets users select various parameters like EEG IDs, sub-IDs, consensus on diagnosis from experts, electrodes, and patient IDs. This selection dynamically updates the displayed EEG data chart. Pretty neat for researchers or clinicians needing a quick look at EEG data, right? Now, about your problem. When a sub-ID is selected, it only changes the x-axis labels of the chart, but it doesn't fetch the new 50-second data segment associated with that sub-ID. That's a key feature for sure, because each sub-ID likely represents a different segment of EEG data, and you need to display the correct segment to make accurate assessments. Here's what you can do to fix this. 1. Adjust the Fetch Data and Update Chart function. When a new sub-ID is selected, your Fetch Data and Update Chart function should be triggered. This function needs to fetch the EEG data for the selected sub-ID. Right now, it seems like it's not correctly updating the data in the chart. 2. Check the data fetch logic. Ensure that the logic for fetching data based on the sub-ID is correct. It should use the EEG ID, electrode, and sub-ID to fetch the right 50-second data segment from your server. 3. Update the chart data properly. Once you have the correct data, make sure that your chart update logic, update chart function, is correctly replacing the old data with the new data. You might have to thoroughly check how the data is bound to the chart and ensure that it refreshes entirely with the new dataset. 4. Offset logic. The offset value you get from the selected sub-ID should be used to calculate the correct range of data points, samples, to fetch. For instance, if your offset is 10 seconds and your sampling rate is 200 Hz, you should start fetching from the 2000th sample. 5. Testing. After implementing these changes, you need to test the application to ensure that selecting a different sub-ID correctly updates the chart with the new data segment. Check for various EEG IDs and sub-IDs to cover different cases. In broader context, this application can be incredibly useful in clinical settings or research facilities where EEG data is routinely analyzed. It can speed up the process of reviewing EEG data, assist in diagnosing neurological conditions, and potentially help in training machine learning models by providing a way to visually inspect and categorize EEG data. Finally, remember, EEG data interpretation is complex, so the tool's accuracy and ease of use are crucial. Always validate with actual clinical data and possibly integrate feedback from EEG technicians or neurologists for further improvements.
Yeah, that was the GPT-4 summary. That's the new voice that they have. I forgot what it's called, but yeah, as you can tell, that robot is pretty incredible. So I just realized that it actually does work okay. I just realized that it potentially does work okay. Here's a few print screens to show you what the front panel looks like. So the first image has a sub-ID 0 with offset 0. And the second image has a sub-ID 1 with offset of 28. Can you review the two images? And also, so we are currently live streaming. So if you can, would you like being a host of this stream? To do that, you will need to give a broader perspective of what this whole application is all about and overview the code I provided earlier. Keep it light. Yep. So let's see if GPT-4 can just take over the stream, keep developing the application, maybe even winning the Kaggle competition, while I'll go grab some coffee. But I'm still listening to what it says.
All right, taking a look at the screenshots you've shared, it seems like the application is indeed updating the data being displayed based on the selected sub-ID and offset. In the first image, we have sub-ID 0 with offset 0, which gives us a dataset starting at 0 seconds. And in the second image, we have sub-ID 1 with offset 28, shifting the starting point of the dataset to 28 seconds. The x-axis of the chart reflects this change, showing the shift in time, which indicates that it's displaying a different segment of EEG data. This is exactly what you're looking for. So, for the audience tuning into the live stream, let's break down what we're diving into. We're working with an application that's a bit like a treasure map for the brain's electrical activity. Imagine you're on a ship sailing the electrical storms of the neural sea. This EEG data viewer is your compass and map. It's not just any map, it's interactive, allowing researchers and clinicians to navigate through the brain's electrical patterns as they hunt for buried treasures of insights into neurological conditions, like epilepsy. The code behind this application is like the crew of the ship doing all the heavy lifting in the background. It fetches data for different segments of an EEG recording, which represents the electrical activity of the brain, typically used to diagnose various neurological conditions. Each EEG ID represents a different patient's journey, and within those IDs, the sub-IDs are like specific chapters of the story, capturing particular events or moments in the brain's activity. The offset is the specific timestamp where you want to zoom in. It's like choosing exactly where to drop your anchor and dive in for a closer look. What's cool here is how this application brings together a cross-section of expertise. Neurologists, data scientists, and engineers all get a common ground to collaborate. It's designed to make the complex task of analyzing brainwaves a bit easier, potentially speeding up diagnoses and research. The viewer also holds promise for teaching. Imagine a medical student, eager to learn, who can now dive into this sea of data, not with a textbook, but with a tool that shows them the real deal. Live, dynamic, and a bit unpredictable, just like the brain. Now, if you're into the technical side of things, the application's backend is a well-oiled machine. It pulls specific EEG data segments and displays them dynamically as you choose different parameters. It's built to scale too, so as more data comes in, it can handle the load, providing valuable insights into patient-specific brain activity. For those tuning in who are not tech wizards, no worries. All you need to know is that we're using tech to peek into the brain's electrical dance, and this tool helps us read the rhythm and patterns of that dance. It's a bit like translating an alien language, complex but fascinating and filled with potential discoveries. The big picture here is a fusion of tech and medicine, each improving the other to help us understand one of the most mysterious organs in the body, the brain.
Can you explain the data structure, the different files, how they loaded in the code? And also explain the different labels, what they actually mean. Particularly focused on the difference between seizure and AVA labels, and also explain the label AVA. Also make a suggestion as to how to load the spectrogram files to be viewed at the same time with the data.
Sure, let's break this down. Data structure and files explanation. This is like the main ledger in the dataset. It contains metadata about the EEG recordings, like the unique identifiers for the EEG data, EEG ID, the specific 50-second long samples, EEG sub-ID, and the offsets in seconds, EEG label offset seconds. It helps you pinpoint which parts of the larger EEG recording you should be looking at. The expert consensus gives you a professional's take on what's in the EEG, whether there's a seizure, for example, or some other kind of brain activity. EEG ID and Spectrogram ID. These IDs are your keys to individual patient data. EEG ID unlocks the EEG recording files, and Spectrogram ID gets you into the spectrograms, which are visual representations of the EEG data. Parquet files and train EEGs and test EEGs / These files are packed with raw EEG data. They hold the actual readings from the electrodes stuck to the patient's scalp, with each column being a different electrode site, except for the EKG, which records heart activity. To view these, your code would load the corresponding .parquet file based on the EEG ID. Train spectrogram / and test spectrogram / Spectrograms give you a visual look at the frequencies in the EEG data over time. Each file here matches up with an EEG ID, showing the spectral data for the corresponding EEG. Labels explained. Seizure indicates that the expert found patterns typical of a seizure, which could include rhythmic spikes or sharp waves across the brain. LPD, lateralized periodic discharges. These are repetitive, sharp waves found on one side of the brain. They might show up with conditions like strokes or tumors. GPD, generalized periodic discharges. Similar to LPDs, but these are seen all over the brain, not just on one side. They can signal a more generalized brain dysfunction. LRDA, lateralized rhythmic delta activity. This is about slow rhythmic activity on one side of the brain, often seen in focal brain damage. GRDA, generalized rhythmic delta activity. Just like LRDA, but it's not just one side, it's generalized across both hemispheres. Loading and viewing spectrogram files. To load and view the spectrogram files alongside the EEG data, you would typically 1. Read the Parquet file. Use a data analysis library like Pandas in Python to read the .parquet file into a data frame. This loads the EEG data. 2. Load the spectrogram. You'd also load the corresponding spectrogram using an image processing library or even just a simple plotting tool if it's saved in a graphical format. 3. Synchronize views. When displaying them, you'll want to synchronize the EEG data view with the spectrogram by using the offsets and subides. This way, when you look at a particular moment in the EEG, you're also looking at the matching moment in the spectrogram. 4. Interactive display. Ideally, you'd want to make this display interactive. So as you navigate through the EEG data, the spectrogram updates to show the corresponding visual representation. You might use a web framework like Flask, which you seem to be using, to create this interactive display. To ensure you're looking at the right data, your app would use the EEG sub-ID and EEG label offset seconds from the train.csv to load the exact segment of EEG data and the corresponding section of the spectrogram. That's the core of the code you've got. It's about making sure you're always looking at the right slice of data for the questions you're trying to answer.
Yeah, some of the files, the EEG files, might get the whole tool freezing up. It's probably because of some NANDs coming through from the server, and the front end doesn't know how to deal with it. Okay, now it did unfreeze. Yeah, that's becoming quite slow. There's a violation. It's taking too long. Don't like violations, do we? So that's some sort of chat.js issue. Yeah, it's doing something. It's not cool. Shall we kill the browser? It's funny how Ubuntu works when something like this happens. I still have control over the machine, but for some reason the mouse doesn't work. So obviously I'm still streaming and everything works, but the mouse, no, now it's back. I might stop it from there. Yeah, it's the browser. Yeah, the browser had 350 megabytes loaded in it. So that's obviously not ideal. Yeah. Now my CPU back. Yeah, so how do we go about it? So it's loading okay on power up. Let's keep this thing. There might be some memory leakage. It's using 106 megabytes. Let's start monitoring the resources as well. Yeah, that's the Chrome with the 200 megabytes. Must be it. Yeah, I mean the Kaggle competition website is taking 100 megabytes. I don't know why. Yeah, 200 megabytes. What? if I'm trying to replicate that error, it's not an error, it's just when there's like seem to be too much data and that the browser is freezing. Yeah, that looks more like EEG. Hopefully we can start moving forward with this tool. Trying to replicate, yeah, now it's becoming less and less responsive. So the other thing, so on Biomedical you have some tools for reviewing EEG. Some of them have an option to, so this one, I would like to improve on it. So I might do this anyway. This is 16 channel implantable electrodes. And this is Plotly, not the charts.js. So it has more control and everything, but a lot of this control, sorry for the ads, hopefully if you are visiting the website you actually get some more relevant ads. Yeah, so this one lets you group the channels by left and right. In this case it will be the odd and even numbers there. So this could be nice. You have an option to overlay them all and select the actual window. So we won't need it for this because we're always showing 50 seconds window. That's how the data was labeled. It's just becoming unresponsive and I don't know why. It's normally when you go to the bottom of this EEG ID scroller thing. Yeah, the offset is only 2 seconds in this case. I don't know why. So that the data is fine this way. It's this Harvard Medical School, so they must have done it correctly because it's Harvard, of course. But it's just, yeah, the data is a bit odd. Yeah, already went over a few reasons. Can have some more. Actually, we're not displaying everything in here. I don't know if we should be making this tool more and more complicated or just start a new one. Probably start a new one. We'll have more options. There's a couple of obvious things. Need to make sure the patient ID is being actually updated. with a workspace handle and it's searching everything. Just try and just give it a name, see if it can explain the context of it. It's nice that it's giving links that actually work. This one is not a link, I don't know why. Get patient ID. So those are the unique IDs. So instead of giving us unique IDs, yeah, originally the idea was that you could filter the data based on all the different parameters. Let's go GPT for a sec. Okay, so looking at the code, I need specific advice. Looking specifically at this file, the train CSV, the different column labels, are we actually using them all? Well, the answer is no, but the original idea for the data viewer was to filter based on patient ID or the expert consensus label type, but that doesn't seem to currently work. Can you try and explain? Look at the code provided above, all of it. Keep it light. Yep. Ba-ba-ba. Yes, the patient ID is not currently being updated. So when you select, for example, EEG ID, is the patient ID being updated to show what is the patient ID for blah blah blah? Doesn't it sense the message without me finishing? So no, the EEG ID and patient ID are different. Well, yeah, no, they're different. In the fetch ID function, the EEG ID is used to fetch EEG. In the patient ID is used. Okay, I was actually asking if one is updating the other. I'm asking if one is updating the other. The text to speech is hopeless. Am I using the correct microphone?
Okay, let's do a quick tour of what's happening with the train.csv in your current setup and how it ties into the data viewer. From your description and the code, It seems like train.csv is the backbone. It contains essential information like patient IDs, the expert consensus on what type of brain activity is occurring, and identifiers for EEG data segments. These details are like the index to a vast library of brain activity. Now, your app aims to be a filter-savvy librarian that can pull the exact book or EEG data you're looking for, whether it's based on a patient's story or the expert's opinion on the plot, the consensus on EEG patterns. But it seems like your librarian is a bit sleepy and isn't fetching the books as expected when asked for a specific story or opinion. Looking at your code, you have drop-downs set up for selecting EEG IDs, consensus, sub-IDs, electrodes, and patient IDs. These drop-downs should let users sift through the library seamlessly. But if some aren't affecting the data pulled up, it's likely because of a few reasons. 1. Missing links. There might be a disconnect between what you select in the drop-downs and how the data is fetched. For instance, you have the patient ID and expert consensus as options. But if the change events for these dropdowns aren't tied to functions that fetch and update the data, nothing will happen. 2. Your data fetching functions need to reference the train.csv fields. They should use the selected patient ID or consensus to filter the EEG data. If they're not considering these fields when fetching data, then changing these fields won't have any visible effect. 3. Event handlers. You need event handlers in your JavaScript that listen for changes in the dropdowns for patient ID and expert consensus. When a user selects a different option, these handlers should trigger the fetching and updating of data. 4. Backend routes. Your Flask app needs to have routes and functions set up to handle requests for data filtered by patient ID and expert consensus. These routes would interact with the data and return the filtered results back to the front end. Here's a friendly suggestion. If filtering by patient ID or expert consensus isn't working, double-check the JavaScript functions tied to those dropdowns and the Flask routes they correspond to. Make sure they are actively filtering the data and that the chart gets the memo to update with the new data fetched. In the spirit of keeping it light, think of your app as a DJ mixing tracks, EEG data. Right now, the DJ is only playing songs from one album, EEG ID. You want to give the crowd, users, the power to request songs from different albums, patient IDs, or genres, expert consensus. To do this, you need to make sure the DJ's mixer, the code, is hooked up to all the turntables, data filtering logic, and not just one.
Yeah, hopefully we can modify this code. Yes, so far it's only the EEG ID that is updating the data, and even that is a bit slow, especially when you go to the bottom of the list. Yeah, they have those example files, so ideally we will plot the spectrogram as well on the same page. So I have this example figures, and obviously as you can tell, right, so this is 0 time -5 and 5. ECG is good. doesn't seem to correspond to one another. And why those are PDFs as well. And the question, all right, I get it. So this is the left lateral, right lateral, left posterior, right posterior. I want to reproduce those myself. They don't seem to correspond to one another. There seems to be something happening there on yeah, I don't see it here. Right, so say this example. Yeah, what's up? So there's obviously, yeah, why don't you see it on the plot? This is 10 seconds. The EEG is 50 seconds. I just don't trust that those actually coming from the same EEG, and obviously that's some sort of averaging of different channels. Yeah, I don't like them at all. Some sort of artifact. Yeah, the ECG is a mess. There's essentially no ECG. Therefore, yeah, can probably tell that that's some sort of noise. Yeah, that ECG is weird as well. Okay, we have an ECG there. Some low frequency components in the spectrograms. Yeah, I want to do the spectrograms myself. We have done this before. We have a tool for it. Yeah, this is also not the best spectrogram, but you want to see things like this. You want to do like a sanity check with your spectrograms to see when the seizures end. This should end. You don't see that in there. There's nothing obviously corresponds. There's something happening. There's something different there in the middle. There's some sort of noise, a low frequency component, but it's not in the time series. It's not in the time domain. That's why I don't necessarily trust it. Yeah, you want to see them one above the other, so these components there, you can actually see that something is corresponding to one another. And here, for example, you would expect a large low frequency component there. You don't see it. Well, this is during a seizure, so Yeah, you kind of see it here. But yeah, you want to see something that corresponds to your signal. For sanity check, yeah, like this one, for example, when you see a spike like that, which is probably some sort of noise, not sure, but you want in the spectrogram to see a corresponding thingy happening at the same time. It's kind of important. So and I don't see it happening there. First, the scale is different. Let's open another one. No, you see, it's rubbish. So supposedly the scale is the same. You have 0 time, -5, +5, whatever. It's a bit odd. But then you have this low frequency component at the end here, but you don't see it in the time series. So it's either been heavily filtered, but then why is this not showing the filtered data? Or there is something wrong. More likely there is something wrong. Yeah, the time series is essentially not telling you what's happening in the frequency domain, or the other way around. Yeah, here we have a good ECG. Yeah, this one is more like it. No, but then you see you have a spike and a deep there before 0 time, which is, you would think it's that one. But then you have one after 0 time as well, which is not on the time series. Yeah. Let's read the description again. Right, so the spectrograms are 10 minutes. Okay. This is 7 seizure, 6 LPD. 15 LPD. There's 1, 2, 3, 4, 5, 6, 7, 8. 20 seizure. Okay, so, so obviously there's no 20 seizures there. That's just one. There's like 20, so that's 20 labels. Okay. Yeah, I'm just not convinced of this data set. Right, so the column names indicate the frequency in hertz and the recording regions of the EEG electrodes, the letter of the abbreviated LL. Yeah, left lateral, right lateral, left parasagittal, and right parasagittal. So essentially left front side, left back side. Yeah, I have to bring up EEG montage. National League Against Epilepsy. Yes, I have a montage like that. So this one will be FP minus F7, F7 T3. So it's a T3, T5, T501. FP2. So by the way, we don't necessarily have to do it. Those are those being digitally subtracted from one another. Just look at the actual recording. Yeah, I never understood why do we need to actually do that. I mean, you do that to reduce the number displayed, but then you actually don't. Yeah, because you essentially can display just 4 things, 4 sides of the brain. But that's you know, if you're doing big data, whatever analysis, it's not necessary. The thing about the patients, ideally we'll have some sort of patient description. The patients will have different type of seizures, and they will be originated from different types of the brain. So you would need the description for each patient where the seizures are coming from. That could be useful. Yeah, anyway, so first I don't necessarily trust those spectrograms. Might try and recreate them ourselves. I don't think we can. Yeah, I don't see those bits in the data. Because do we have the 10-minute recordings? No. No, we don't. We'll have to look at the spectrum files. We would not be able to generate them ourselves. Yeah, so the experts labeled 7-LDP, 7-LRDA from this 10 minutes. It's quite an achievement. So we won't be able to display it like this because the original data is only 60 seconds. It's much shorter. Yeah, just the problem. Yeah, the dataset is not very transparent. So I understand they have more that they, once you submit your algorithm, they test it on a hidden, non-public set as well. But then even with the data that is provided, definitely more be done. Yeah, the other problem is that even if we display the spectrogram here, it will not be in the same format. In terms of the time window. So this will remain 70 seconds. The spectrogram will be 10 minutes. Let's see things that look more like seizures. Yeah, it's not. Again, I don't believe that's the spectrogram for this thing. There's something wrong. There is something wrong. So this essentially means that one of those should have this a lot of it's called the left side should have a lot of slow wave activity, and you just do not see it. You do want to be able to switch between this montage and how it actually was recorded. So you essentially have this bit and that bit. Some sort of weird convention, don't really need to do it. Then you have this bit, you have that bit, and then the bit in the middle. Just because it was done like that for many years, you don't have to do it in the same way. And yes, you have odd and even depending on the side. The ones in the middle you can most of the time just discard. This should be telling you something about the interaction between the left and right hemisphere. But again, this is Harvard Medical School, so it must be correct.
All right, I see where we're at. You have the fundamental structure in place. And now you're looking to ensure that your EEG data viewer can filter EEG data based on different criteria like patient ID and expert consensus. From what I can gather, you're looking to accomplish a couple of things. 1. Filter data based on patient ID or expert consensus. You've got drop-downs for these, but they might not be hooked up to change the display. What you need is a way to tie the selection of these drop-downs to the data being shown. 2. Fetch and display the filtered data. When a user selects a different patient ID or expert consensus, the displayed data should update to reflect this. To get these filters working, you'll need to do a couple of things. Front-end JavaScript changes. For the dropdowns that are not currently affecting the data, like patient ID and expert consensus, you'll need to make sure that changes in their state trigger a new data fetch. Right now, you have event listeners set up for changes on these dropdowns that call Fetch Data and Update Chart. Ensure that Fetch Data and Update Chart actually uses the selected patient ID and expert consensus to fetch new data. You might need to modify your API endpoints to accept these as filter parameters, and then adjust the front end to pass these parameters when making requests. Here's a quick sketch of what the updated function might look like. JavaScript async function fetch data and update chart, const patient ID, document.getElementById by ID, patient ID value. Const expert consensus equals document get element by ID, expert consensus value. Adjust the API endpoint to include filters for patient ID and expert consensus. Const fetch URL / fetch each EEG data, EEG electrode equals electrode, and start index, and end equals end index n. Patient ID patient ID'd, and expert consensus encode your component expert consensus. Now use fetch URL in your fetch call, existing fetch logic. Backend Flask changes. On the backend, you'll want to update the /fetch EEG data route to handle the new filters. Python @ route /fetch EEG data, methods get. Def fetch EEG data, EEG ID equals request.args.get EEG ID. Electrode request.args get electrode. Patient ID equals request.args get patient ID. New filter expert consensus equals request.args.get expert consensus. New filter, existing code. Fetch the data and filter based on patient ID and expert consensus. df equals df patient ID equal patient ID, and df expert consensus remaining code. Make sure that your datautils.readscored.csv and datautils.readParquet functions can handle these additional filters, returning only the data that matches the selected patient ID and expert consensus. Testing. After implementing these changes, thoroughly test the application. Select different patient IDs and expert consensus options to ensure that the displayed data updates accordingly. Keep in mind that to keep things efficient, you might want to limit the amount of data being transferred. If your EEG datasets are large, consider loading summaries or slices of the data that can give users the insights they need without overwhelming the browser. These changes should get your EEG data viewer's filters up and running, letting users navigate the neural seas with a more precise compass.
funny thing about this dataset is that the experts were presented with 50-second time windows that are essentially identical. So in this case, yeah, the windows are 50 seconds, but the offset essentially means that they always overlapping, so essentially the same. I think that's probably how the data was extracted, like how the labels were extracted from the original labeling, because normally, so they essentially labeled in this case 64 seconds with a seizure, and for whatever reason there were 4 or 5 labels extracted out, 5 50-second labels extracted out of this 64 seconds of seizure, which is a bit odd, but can't change the data set. Yeah, it looks like some spikes in there. Spikes are on some channels, not others. This one's really odd. Yeah, ECG is bad. The ECG electrode could have been, just coming off. Ideally, we'll have, with this data, you will also have impedance measurements. They normally help you clean up the data. There's obviously was some data in there that has a lot of noise, and that's probably not this type of noise. This type of noise probably suggests that something else is wrong. I bet the ECG for this is also not. Oh no, I was wrong. The ECG is there. Looks good. Some DC offset, but it's okay. But come on, the data. Yeah, something is up. Something is wrong. Yeah, I need to make sure seizure is actually updated correctly. And you're reaching the 4-hour mark. I might do some more offline. Let me know if you want to collaborate, team up for this competition. I'm not fast with actually winning, it's just for learning. So don't worry about what I don't even normally look at the leaderboard. Yeah, if you manage somehow to get up there, it's a bonus. Otherwise, you learned a lot. And yeah, go check out biokurious.com. Has a lot of relevant tools about the ECG, EEG processing, in this case, EEG. And I'll see you